This is eHobbyist blog, a log of electronics hobbyist activities aimed at city dwellers who have limited space, limited money, and limited time. My name is Neil. Welcome. During this video, we will fabricate a printed circuit board for the variable positive power supplies. Wiping water off of this board. I haven't done much of this stuff recently, but I remember you've got to keep the copper scrupulously clean and degreased. I'm applying polyimide tape. Last time I used Scotch tape and it was kind of shaky and sloshing around. I'm taping the printed traces. This time I printed them on paper rather than clear overlay and maybe get better results. Every time I've tried the transparency paper, I only get about 90% transfer. And we now apply the iron. What I'm trying to do is to remelt the laser printer toner and get it to adhere to the copper. This iron keeps cutting out when it thinks it's been left sitting on someone's shirt, and so I have to continuously move it. The question in my mind has always been, what is the optimum time for this sort of thing? I've heard different times, ranging from 5 minutes to 8. I'm going to go for 6 minutes this go around. Trying to press down, apply a lot of pressure against the paper. The idea for the paper is that I won't have to peel off the transparency film. I'll just kind of dissolve the paper, repulpify it, and roll it off, leaving the toner behind. At least that's my thinking. And maybe I can get better transfer with that. What is attractive about the transparent film is that you can see through it, and you can see exactly where you're going. And I suppose if you wanted to, you could apply several layers of toner by aligning one transparent film against another, previously done. And at 6 minutes, I am now taking this off, peeling away the polyimide tape, and trying not to disturb the paper quite yet. I'm not ready for it to be disturbed. I want to dissolve the paper. Now I've got a hot plate setting to low. Put the paper in and let it get soggy and turn to pulp. How long does this take? A long time. Cut the down. No, don't boil the water. Oh no, a little too much vigor in the heat setting there. Now, how long is this going to take? It's approximately anywhere between a half hour and an hour, and it doesn't really matter to me. I just let it sit there and get truly soggy until it can get rolled off. As I'm doing now. And this is after 11 minutes. That's actually a little too soon. I hope I'm not going to pay for this. I'm rubbing very gently. This paper comes off in 2 layers. There's a top layer that's kind of thick, and then there's a bottom thin layer that's just up against the copper. There's nothing strange or weird or expensive about this paper. It's the cheapest laser printer paper I could find. Getting there. Just important for me not to get carried away here. I'm now half an hour into this. And just gently roll the paper off the copper without disturbing the toner. It doesn't look too bad right now. Still a little to be done. Yeah, doesn't look too bad, actually. It looks better than I thought it would. I didn't have the same problem I have with the transparent film, where 10% of the area so just doesn't transfer, stays on the film. This looks pretty good. Okay, I'm stopping it at 35 minutes. I'm going to let this dry, and while it's drying, I'm going to fill areas that contain no circuitry and use them for ground. Save a little etchant by just covering this up with liquid resist, known in some quarters as nail polish. Nail polish is really good, but I don't know how to make fine traces. I've also used laundry markers as liquid resist, and they sort of kind of work, but the lacquer, the nail polish, does work very well. No, ouch! Oh, we're going to have to fix that. Sloppy. I have to watch some more Bob Ross episodes. That is not a happy little accident back there. Pulled a short. I'm using a scribing tool to scrape off the nail polish, the lacquer, where I short-circuited a trace. Now, I let this dry for a while, and I'm about to etch it. I'm using ferric chloride as an etchant, an oxidant. Oxidizes the copper, converts the copper to copper chloride. Ferric chloride, the iron gets deposited as basically rust. Ferric hydroxide to ferric oxide. I don't know. I used to know the chemistry of this stuff. What it does is dissolve that copper that is not protected by resist, converts it to soluble copper chloride. Now, the problem is I have no idea what the quality of this etchant is. some of that copper is beginning to dissolve away. Got to keep my eye on this. This is proceeding a little faster than I thought it would. I've seen quite a number of YouTube videos on how to do this sort of thing, and the speed of etching was enormously improved by rubbing down the circuit with a sponge, or in this case I'm using a cotton ball. The etchant in contact with the copper is being continuously renewed as the copper chloride is locally removed from the spot where it's being etched. So even with this old etchant, things are going pretty fast. 14 minutes, well, not all that fast. There's a vast area of this board in the middle that's already done. I don't want to over-bake it, so to speak, because it will begin to undercut the resist. It's almost all done here. It came right along. 15 minutes, however. Okay, so maybe I'm going to have to get a new batch of etchant. You should renew the etchant at least once every 30 or 40 years. That doesn't look all that bad. I'm astonished. I thought I'd have a lot of trouble with this. That's a good-looking board so far. You don't really know until you get the resist off, which I'm dreading. Acetone being used to remove the resist, and here I go. I'm not going to look at this. I'm going to close my eye. I can already see that a lot of these traces have been pitted and undercut. I've done better printed circuit boards in my day. I've also done worse. I hate to admit it. This looks like it might be workable. I haven't seen anything really bad. So, I see a broken trace. It's in the middle. Yeah, that's the only one I see, though. I get a better view by looking at it backlit. Okay, I think I'm going to examine this more closely, and if it's usable, I'll proceed, and if it's not, I'll redo the board. In this video, I printed the variable positive power supply circuit board traces on standard paper using a laser printer. I transferred the traces to the copper side of blank printed circuit board using a laundry iron. I used hot water to loosen and remove the paper backing, leaving the printer toner fixed to the copper. Then, using that laser printer toner as etchant resist, I etched the board. In the next video, we will continue fabricating the variable positive power supplies. If you like this video and the idea of the channel, click on the YouTube thumbs up icon. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.